Thanks, Paul, for the introduction. Thank you all very much for being here. I know there's 3 terrific talks taking place at this very moment, possibly the only downside to this fantastic conference. So yes, as Paul said, I'm a researcher at a Center for Digital Music, which is just 2 or 3 tube stops away from here. We tend to think a lot about how to augment, enhance, or completely renew music production tools, mixing tools, mastering tools, and so on. And it's from this perspective that I'll be giving this talk today, identifying some of the challenges that you as a developer specifically might run into and might want to think about. So all in all, it's a great time to be alive. You can tell your computer, make the guitar sparkle, and with speech recognition, it will even be able to parse that from speech, but unfortunately at this point it's not going to be able to do anything with that yet. Instead, the state of the art is as follows. You need to list a number of very esoteric parameters with very detailed values, and then if you're an expert or just really, really lucky, you'll be able to make this guitar sparkle in effect. So in other words, the parameters are really informed by the implementation, and not even the code necessarily, but actually legacy analog implementations, and not, as you might hope, by perception. It's not really intuitive, and the controls aren't really semantic in any way. So this is something that we as a group want to address, and I know a lot of other people are interested in this as well. So the fact that you still need an expert operator at the mixing console, for instance, or at the computer to make things sound good, essentially, is in stark contrast to some of the other areas of the music production chain, so to speak. On the recording end, you've got very, very cheap hardware and software, which is hugely democratizing music production in general, and the quality of this by far exceeds even the most expensive studios of, let's say, the 1960s. And on the distribution end as well, we're spoiled for choice, as the internet is really connecting the music producers or musicians with their fan base and with anyone who wants to listen in. So we've got a bit of a vacuum in between these 2 ends of the music production chain, which I call mixing here, but of course it's also editing and mastering and all of the related stuff. So this is something we might want to democratize even further. The digital revolution has, of course, and by that I mean the increase in performance of hardware and so on, has of course led to huge increase in the number of tracks that you can have simultaneously in a music production session, the number of plugins you can run concurrently, and the quality of analog emulations. But it would seem there's not really an exploitation of the huge number of possibilities that the digital realm might afford if we're going a bit more creative about it. One of the possible reasons for this is that there's generally a lot of resistance to the general idea of a machine replacing a human, and exceedingly so for such a creative task, any task which is part of the music production process. So to this, I offer an increasingly popular analogy, which is comparing music production to photography. The reason for this is that photography is also a very hybrid, technical, creative task where you have to think about technical parameters in order to have an artistically pleasing result. So it fits in that way. However, in photography, we already take automation of parameters for granted to a very, very large extent, including autofocus, auto exposure, smile detection, all of these features which we don't really think about anymore. And this is great for amateurs because without knowing anything about camera technology, we can snap pictures which are usually half decent. But then for professionals, it's great as well because they get to be more efficient. They get where they want to be quicker, and their creative flow is really uninterrupted as they can really focus on the artistic aspects. So this could happen for music production as well, mixing in particular. by automating all of these esoteric parameters to some extent, again, facilitating the process for the amateur as well as the professional. Another reason for looking into automatic production of music, automatic musical signal processing, is the sheer volume of content that is being created. And here again, I want to draw the parallel with photography, as it has been estimated that at some point in the recent past, the number of pictures that was taken over the course of 1 year was equal to the number of pictures that was taken in all of human history, or in all of the history of photography before that, which is quite significant. And a more cynical person than me might remark that the quality has decreased proportionally. Maybe something like that can be said for music as well. I'm not going to venture those opinions here, but the fact that such a volume of music is being created, and of photography, means that there is no number of sound engineers available that can process this, so technology can step in to catch up with that. And if you would allow me to overextend the photography analogy even a little bit more, there's quite often, in response to this kind of research, these kinds of considerations, there's the concern that, what about creativity? Aren't you taking away the control from the user, and aren't you making something which is very consistently the same, music sounding the same all the time? Again, some cynical people remark that we're already there. But to that, I again point to photography, where applications like Instagram, for instance, give some sense of creative control, but they're more intuitive. They're basically just clicking a preset or sliding a very intuitive fader to achieve a creative result and to have some diversity in the outcome. So if you would imagine an application like Instamix, if you will, we can work on the name, but you could imagine that you select your favorite famous mix engineer, or a particular era, or a particular production approach, and use that as control for controlling how your mix is going to sound. Staying in the visual area for a little bit, I just added this slide in because of an interesting conversation that I just had. So there's a concern as well for jobs, obviously, and this is mostly from the audio engineering point of view. For developers, this is mostly good news, I think. Of course, if you're going to automate a lot of stuff, then maybe there's a concern that the industry is going to be overturned, and then jobs are going to be lost. And I'm not here to contradict that or to definitely say what is going to happen, but I'd like to think that, for instance, when photography came about, the visual arts didn't just disappear because of photography, but it probably did evolve because of that. So a realist painter may have had a less interesting job because photography was around, but then there was some very interesting art which came afterwards. This is all very simplified, but I hope you get the idea. So the point I want to make is that perhaps it is true that some of the more mediocre artists who are effectively being replaced by a sort of a benchmark realist technology like a camera are actually going to have to look for a job because they don't really reach this benchmark. And maybe the same happens for music production. I hope this is somewhat clear, where you've got a system that automatically does a mix, and if you're not even as good as this system, then maybe you shouldn't be charging people for your mixing. But definitely there are going to be more artists out there who will still have a job, or who can really use the technology to their advantage, as we've seen multiple times in the history of audio technology as well. At this point, I'd like to number a couple of categories of types of applications that might emerge in this realm. And one of them is what I call a black box, where really the user doesn't really have any knowledge of what's going on inside, and also doesn't really have control over what's going on inside. And a lot of the already existing systems are actually in this category, especially in the academic realm, because we like to just present something which does something and we don't touch it and it works. But this is actually a model that is very relevant for a couple of applications. For instance, if you've got a small live venue where there's simply no sound engineer available, or certainly not a sober one, then a system like this might be very interesting, especially for monitor mixing, for instance, because you might not have a monitor engineer even if you have a front of house one. In case of a band rehearsal, it's very rare that you have a dedicated sound engineer there, unless you're a very famous band. So that's where this makes sense as well, especially if nobody knows anything about sound engineering. And a bit different, there's been a lot of development in the area of automatic composition, and there, of course, it's not possible or desirable to have a human engineer being present, in which case you need a system that just does the job, no questions asked and no human interaction needed. But a bit less drastic would be the idea of a virtual assistant engineer, especially as the studio apprentice model sort of disappears. So this might do some of the heavy lifting for you and provide you with a starting point where you can then come in and tweak stuff and just get to where you want to be faster. So that's one approach. You might be able, in the case of live sound, to use this as a sound check. So the band comes in, plays a little bit, and the parameters are being set up sort of where they need to be, and you can, again, start tweaking. A bit complementary to this is the idea of a smart interface where you're still doing all of the controlling, but just the controllers are actually more intuitive, more in line with what you expect and with how you think in sort of a creative flow kind of way. So in other words, the parameters are semantic and perceptually motivated rather than very esoteric and based on the implementation. And this is an example of a commercially available plugin. So in this case, you turn an intensity knob rather than attack time and queue and so on. So you might actually be controlling a combination of traditional processors rather than adhering to the traditional separation of frequency processing, dynamics processing, spatial processing. This is something we're looking into as well. And finally, the least controversial, so to speak, would be to completely preserve the traditional controls and processes, but actually to introduce some alerts or some kind of suggestion based on very smart metering. So in that sense, it would be extending the already ubiquitous loudness meters, goniometers, spectral analyzers, and become something which is telling you what's the general amount of reverb on this mix, or how boxy are your drums and should you do something about it, and so on. So at this point, I'd like to identify a couple of challenges between going there and where we are right now. I think they mostly relate to the infrastructure that we have to work with, specifically the digital audio workstations. So this will relate to plugin developers, first of all. So the architecture that we have is not really multitrack. You can do some clever side chaining, but it's not really native to the audio software that we're using. And this is a shame because for a lot of these more intelligent applications, we need cross-adaptive functionality where one track is aware of the contents of another track or what another processor is doing. And also you might want to actually listen in on the output of the mix and how that is being changed in response to how you're processing what you're processing with this plugin. As I said, you could do some side chaining, but it's basically up to the user to set this up, and it will be very cluttered. It's not very interesting. So in order to have a simple setup, a multi-track plugin architecture might be what you want. It also allows you to model larger systems of any sort, whereas plugins are very single track and very here and now in terms of the signal. And such an architecture, this is not really relevant to the point per se, but such an architecture might be interesting for spatial applications as well, where you're in a lot of those sort of restricted to standardized setups and formats. So this is a bit of a chicken and egg problem, as the DAWs obviously don't have this functionality yet, so the developers won't develop for it, but then the DAWs might not change it if there's no plugins that really require this. At this point, I should acknowledge some DAWs out there. I'm not sure if this is all of them, but these are some DAWs that we use because they have some multi-track capabilities. You can have tracks with pretty much arbitrary number of channels. They're Reaper and Audio Mulch. So when we demo some of our inventions and products of our research, then it would often be in these DAWs. Another very important challenge is to provide the infrastructure for learning, machine learning specifically, as you want to build intelligent tools. So first of all, you need a critical mass of data, and we've got some projects in that realm, such as the Open Multitrack testbed, where you can find lots and lots of multitrack recordings, mixes, and metadata pertaining to all of these songs and individual tracks, so you can find what you need quite easily. And I'm also quite hopeful that projects such as this web-based DAW from collaborators at Birmingham City University can provide us with a large body of data, and especially a methodology to collect this data and learn from it on a plugin level or even a DAW level. We also need centralized data collection, so we don't just want the plugin to learn on one user's machine, because then it will just learn what that user likes and not necessarily how to mix in general. There's always a trade-off, you may be familiar with this, between accumulative methods which learn over time and sort of converge on a more ideal result. But then something changes quite drastically in the input signal, and you want to respond to that quickly as well. So where do you find this trade-off? Maybe using time constants, maybe using outlier detection. This is an open question as well for any application in this area. Feature validation, by this I mean that if something changes in the input, which is quite odd, your system should still produce a pleasing output and shouldn't make you deaf or anything. So you need to validate what's going out, what's coming in, does it actually make sense, or do we need to go to some default behavior, for instance. And this is a bit more wide than just learning, but you want to have access in many cases to the whole audio stream, where plugins are very real-time, very barring some look ahead and some memory inside the system. You don't generally read the whole project, and you're not really aware of the whole context or the structure. So you might want access to the whole audio stream in these cases, but DAWs don't really natively support this. And finally, but very importantly, I think, is the interaction of a human and computer in this system. So maybe your system is learning something and it's thinking, oh, this is how I should mix, but you don't really agree as a human. So do you just take over the wheel like you would in a self-driving car, or do you give it little nudges left and right, and how do you implement this? This is a huge research area on its own. So that's something to consider as well. Finally, the semantic and perceptually motivated controls I was referring to, that's another problem entirely as well, because which are the relationships which we need for this. We don't really have definitions of what it means for a source to be punchy or creamy or anything like that. So we need some, actually need some research on this to connect the perception to the signal transformations. And this is something that we're quite active in, and I'd like to quickly present the project, because it's actually a plugin in a way, so I felt it's quite relevant. And this was also presented here 2 years ago in some form. So we got a bunch of mix engineers, actually a very large group, because it was based on free plugins that we put online. So lots of people are using it. And these people take some audio and in their DAW, and they process it, and they say, oh, just made this bright. This is now punchy. And we're obviously storing all of this data. And then the idea is that later on someone can come along and say, look, I've got this drum kit here, how do I make it bright? And then the computer says, well, this is how. So it's not quite that simple. But these are the plugins. They're made with Juice. Thank you very much. And this is, for instance, a compressor where you'll find the traditional controls that you expect on a compressor, contrary to everything I've been saying so far. But then you also have a text box where you can describe what you're doing or what you've just done to the signal. In this case, you say, oh, I just made the snare drum punchy. And then afterwards, somebody can come along and say, oh, so I want to make something boomy, if that's something you'd ever want. So you type BO, and then some descriptors show up. There's also some metadata which you can enter, which is especially interesting for us because we use it to do more in-depth research here. So, quick overview of the system. You've got the plugin, you've got a save button. This is important because it listens to the incoming audio and then takes audio features from both the input and the output of the plugin, saves it along with the parameters, along with all of the metadata and the term into some huge database. Well, not huge, but into a database. And then afterwards, you can go and load, and it will again listen to your audio and modulate the parameters based on some of the information in the database and the term that you chose. So simple enough. We then did some interesting research, or I think it's interesting, on based on all of the data in the database. And for instance, one thing we can do is to look at how different terms are actually similar to each other in terms of the features, the audio features they represent. So thin, clean, cut, click, and tin are quite similar. We can also look at the parameters. So you see that, for instance, the density knob on a reverb, if you turn it up, you'll make the sound big, huge, and massive. So maybe this is a quite semantic knob after all, but the other ones definitely aren't. And finally, there's the case of the known unknowns. We want to deviate from what we know, so all I've shown so far is basically relating to the state of the art and what we've already been doing to some extent. So maybe we want to do new things. And I find this quote quite fitting in this context. If I had asked people what they wanted, they would have said faster horses, said Henry Ford allegedly. Of course, Henry Ford never actually said this, but I think the quote is still quite fitting. So maybe we don't need to make faster horses for the next ADC. We want to invent the car and do something entirely different. And on this note, I want to give you a bit of homework for ADC'17. So by that time, you should be able to just tell your computer, make the guitar sparkle. Computer will listen to the incoming guitar and then do the translation to all of these esoteric parameters himself. And voila, a sparkling guitar. So at this point, I very much welcome any questions, both now and on the YouTube channel and afterwards. So thank you very much for your attention.
Has anybody got any questions?
Hello, quick question. So when you say, when you give, like, let's say an equalizer for like a guitar to be bright, does it look at other audio channels to determine what bright might be? Because bright might be, you know, one thing for one mix, but another thing for another. Does it take into context the other tracks?
So for the last thing that I shown, which was actually some of the plugins that we made, it doesn't do that because that's actually not a multi-track implementation. Conceptually, yes, you should definitely do that, but this particular project didn't really. We have done some multi-track EQs, but those weren't really semantic in nature. Those would do one specific thing, which was usually demasking. So in that case, it does listen to the other tracks. What does it mean to demask a guitar so that it's more apparent and less cluttered? For that, you obviously need to look at the content of the other tracks, and then it adjusts it accordingly. But the thing you're describing, which should definitely happen, is not something that we've done specifically. Yeah.
I just have one more quick question. So the descriptions of the presets those are crowdsourced? Is that Is that correct, or is it from just me as the user? So basically, does the plugin get updated from, you know, so if somebody else?
No, it's, sorry, yeah, I didn't understand that first, but yeah, it's crowdsourced, so it's from all the users together. You can set it to just you if you just want to make your own adaptive presets, but by default, it takes it from the whole database, and it also uploads your information to us, which means we can do research on it. Yeah.
And is there, you know, because you're going to have some producers that are going to upload kind of data that might not be accurate. How do you handle that?
That's a very good question. So first of all, what is accurate? So punchy to you might not mean punchy to me. So sometimes there are outliers or very weird terms, like we've got several entries of sofa, which I didn't think was an audio descriptor. But you've got some of these outliers, and there's several ways of dealing with it. One is to just count on having enough data so that those things are sort of smoothed out anyway. That's sort of the least problematic way of dealing with it, scientifically speaking. But you can also identify outliers in some way, either say, okay, outside of one standard deviation, we just don't look at it. Or do actual outlier detection in a machine learning sense. You can definitely do that. Yeah.
Okay, so if I put a Boomi, let's say I put a Boomi setting, and that's a crowdsourced preset, is that just kind of a median of what everybody has kind of described as Boomi, or?
Yeah, so at the moment it is, because we don't really have the intelligence yet to do very clever modulation of the parameters. That requires some more in-depth research for starters. So yeah, at this point it's sort of an average just based on your descriptor, and in the case of an EQ, for instance, the average curve that you get. So it takes averages, not medians, I think. But yeah, that kind of concept. Yeah, thank you.
Any more questions?
Do you think that this is a right way to normalize audio production? I fear that everything sounds the same after a while, because you have preconditions like sound bright, and everything should sound bright. I would say let it sound so that it's successful on the market.
Okay, yeah, that might require slightly bit more research.
if you found so much, if you know the earlier records from eels, there is one daisy in the dailies. I think then the sound of the voice is very thin, very bent, and this makes it special.
Yep.
And every other sound engineer would say, "Oh, you didn't did it right."
Yep.
But he is distinguishing it with it. All these auto-tune things, I would say, from a musical point of view, don't do it. But they overstress it a bit in the moment. But I think this is, I don't see it, it's maybe for the average people, a mean to make a reasonably good sounding mix. Is it this way? I see it this way.
It's definitely a use case. I see it a bit broader than that, but who's to say what will emerge? It's a very interesting topic, and I have a lot to say on it, but I'll try to be brief. So yes, there is definitely the concern that when you have something that's completely automatic, in sort of the black box case that I presented earlier, you do get like a one-size-fits-all mix, and it gets a bit boring. But this is why I'm actually also presenting a lot of the smart interfaces, where you still interact with the computer and you still say, make this brighter or make this eel's vocal thin, and so on. So you've still got some creative control over that. To go a bit further than that, and it's been raised in a previous talk, I think maybe Stenen's, once you have a device there which does a technical task like auto-tune, like a dynamic range compressor, which was really invented for adjusting a fader over and over. People are going to use it in creative ways. People are going to abuse it, and especially if we make it so that it can be abused to some extent in somewhat beautiful ways, which we can't really anticipate. So I personally don't think that creativity is just going to go away because of some more or less technical system. But this is just my point of view.
Another question then. Would you think that the sound engineer, like that constructed or promoted this Waves plugin, it's from Waves, use it himself?
Oh, I've no idea. I mean, I would hope so. It would be a bit sad if they didn't.
But I would not say. I have luckily listened to a session with Alan Parsons, a well-known producer in Abbey Road Studios, and it was so amazing. And when he was asked, "Did you use the compressor?" No compressors.
Right. Yeah.
Just
yeah.
an SSL console.
Yeah.
This was amazing to hear, and everyone thought that he did something fancy, but his drum sets was so bright and so transparent.
Yeah. Yeah. I mean,
this is the magic behind
Yep.
the thing.
Yep. So definitely, I think. I mean, you've got Al Schmidt, who barely uses any EQ and does everything on microphone positioning. But then there's also engineers which are very successful based on their very heavy compression and so on. So there again, there's really no one size fits all. Yeah. I can't speak to any particular engineer in particular. Yeah.
Wonderful. Cheers. Yeah, I like the idea to gather information from mix engineers and attach it to a speaking name to gather knowledge about what these terms mean. Do you make this interface to gather these analytics? Is there like a common platform? So if there's if I have a plugin and I say I want to use that to gather information, so I could integrate that in my plugin and it would send the data to the big data store and we can learn out of it?
Yes, great question. Actually, on the YouTube channel of Juice from the Juice Summit, so 2 years ago, Sean Enderby from our collaborators at Birmingham City University was presenting a Juice module based on with which you can make such plugins. So basically the back end of the plugins that I was showing. So yes, please check it out. So the name of the project is SAFE, which is Semantic Audio Feature Extraction. There's also semanticaudio.co.uk, which is currently not here, but please do check it out if you're interested.
Cool.
Yes, thank you.
There was one quick question on the internet.
Oh, nice.
Do you find procedurally constructing a pleasing mix is a complex challenge, or are there straightforward rules like a pink noise envelope, loudness curves, etc.? Oh,
yeah, definitely complex. I should note, actually, there's tons of slides that I didn't use, but at the start of my PhD, which is already a while ago, what I've done was just taking some simple rules from audio engineering literature, like how to be a mix engineer kind of books, and just put them all in a machine. And I actually made mixes which were kind of preferred and sort of on a par level with some good human mixers. But it's not very, so you can sort of take a couple of very effective rules and make a knowledge engineered system this way, but it's not very scalable. It's, if your guitar is a bit too bright or there's some artifact, the system won't really hear it because it's just doing like these one size fits all rules. So this is the point where I said, okay, we need more information about perception of mixing, and this is how I went on to do more perception-based research and more psychoacoustic tests and so on. So yes, definitely a very complex challenge. A lot of people have been working on it in the last 10 and especially 5 years. It's definitely not a solved issue.
There was one more question over here.
Thank you.
Hi. Given that producers are quite precious over their work, artists, we don't want our stuff to be ripped off, essentially. Did you find it a challenge to get people to contribute allow you to use their audio features as part of your data set? And if so, how did you mitigate that problem?
Okay, that's a really good question. Actually, I didn't really run into that much resistance, but I should say that only some of the people I worked with were Grammy-winning mix engineers who were, by the way, very supportive of the idea. But most of the people I've been working with are actually students from esteemed sound engineering programs all over the world, and for them, for them and their educators, there's definitely the benefit of getting a kind of peer review system. This is nice. Yeah, sort of a peer review system where you've got several mixes of the same song, and then people listen to it and give them feedback. So what I did was then give that feedback to them, an anonymized list of comments on their mixes and so on. So it was a very valuable experience, which is probably why they were happy to contribute. And also sometimes their teachers just said, you have to do this, which helps.
Okay, I think we're out of time now, but if we could give Brecht a big hand for a great talk.
Yeah, thank you.